Hi, so here's another interesting question under line integrals, and we are told to say we have to evaluate uh, what we have here, and we are told to say where c is the curve along this vector valued function, and the interval we are given minus 2 pi um, to 2 pi. Okay, so first things first, uh, we have to find the derivatives, of course. Yeah, so here we are going to have x of t. What do we have? We have 4 cos t. Then y of t is simply equals to 4 sine t. Then z of t is simply equals to 3t. So x prime of t is simply going to be equals to minus 4 sine of t. I've just differentiated that one there. Then y prime of t will be equals to 4 cos 4 cos t. Okay, then z prime of t will be equals to 3. Okay, so if we introduce that square root, let's see how this is going to end up to be. Okay, so here we are going to say x prime of t squared, which is simply minus 4 sine t squared. So you observe to say this, actually, let me not even waste time. This is going to give us positive 16 sine squared t. Okay, then plus, if you square this one, you're going to end up with 16 cos squared t plus, if you square 3, okay, that's going to be a 9. So what do? You can actually factor out the 16 here. So this is going to be something like this. Uh, it's going to be something like 16 here. Then here you're supposed to have like something like uh, sine squared t plus cos squared t plus 9. But of course we note, say, from trig identities this is equals to 1, so I don't have to place it there. So it's just actually 16, uh, it's just 16 plus 9. Okay, 16 plus 9, which gives us 25, and we end up with a 5. Okay, so this is a 5. So let's go ahead and work out the other part. Okay, so for me, I find it much easier to first of all work out the derivative, then I just go ahead and plug it in. Like it will just be a constant, something like that. So it's like I can just place it outside here. Okay, then the integral. Then I'm integrating from minus 2 pi to 2 pi. Then what I have is this one here. So you remember to say where there's x, where there's y, you're supposed to substitute with the expressions for x as well as for y, what we have here. Okay, so if you substitute 4 cos t where there's x squared there, of course we still have our square root. Uh, still have our square root there like that. Then this is going to be 16 cos squared t like that, plus even here you're going to have 16 then sine squared t. Okay, so this is now is going to become dt. But before that, remember I was supposed to multiply by the square root of, here I was going to say x prime of t squared. I've already worked out that, which is this one here outside. Okay, so that's why I like working out that first part, so that I'm going to save some space and time. Okay, so this would be uh, something like from minus 2 pi to 2 pi. Then if you factor out the 16, this would be like the square root of 16 open bracket. So you observe to say you're going to have cos squared t plus sine squared t. Then this would just be a 1 actually. So it's like the square root of 16, which is a 4. Okay, that would be 4 dt. So it's like you're going to have 4 times 5 is a 20, then the integral here with respect to t is simply a t. Okay, then evaluate from minus 2 pi to 2 pi. What do you end up having? This will be like 20, then you say 2 pi minus, open bracket, minus 2 pi. Okay, what do you have? This will be like 20 multiplied by 4 pi, which gives us 20 by 4 is 80. Okay, so we have 80 pi as the answer that we were looking for. So that's how we answer this question. You can check out the link of the previous video in the description. Thank you very much for watching, and look at you in the next video.